Factorization of quadratic expressions using a grouping method. The general form of a quadratic expression is ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The expression has three terms. The term in x squared is ax squared. The term in x is bx, and the constant term is c. Now let's solve an example. Factorize the following quadratic expression by using the grouping method. The expression is x squared plus 8x plus 12. Remember, in grouping method, we will always split the term in x. The term in x in two numbers such that the sum of those two numbers is equal to the coefficient of x. The coefficient of x, what is the coefficient of x? The coefficient of x is 8. So the sum of those two numbers must be equal to plus 8. Plus 8. And the product of those two numbers must be equal to the coefficient of x squared. The coefficient of x squared, what is the coefficient of x squared? Coefficient of x squared is 1. So the product of those two numbers must be equal to 1 multiply this constant term. This constant term. So the product of those two numbers must be equal to the coefficient of x squared multiply the constant term. So let us say those two numbers. Let us say those two numbers are a and b. Then a plus b must be equal to plus 8. The coefficient of x must be equal to plus 8. And the product of those two numbers must be equal to the coefficient of x squared, which is 1, multiply this constant term plus 12 is equal to 12. So we need two numbers whose sum must be equal to plus 8 and whose product must be equal to plus 12. So think about two numbers. What about 6 plus 2? 6 plus 2 is equal to plus 8, and 6 multiply 2 is equal to 12. So we can split this 8x into 6x plus 2x. So let's split 8x. So we got plus 6x and plus 2x. It's same. Plus 8x is equal to plus 6x plus 2x. Now let's write the remaining terms. Let's write the remaining terms, x squared and then plus 12. So now we have four terms. Now we have four terms, 1, 2, 3, 4, and we can group these first two terms and these last two terms. So let's group them. Now we have two groups, and due to this grouping, this method is called grouping method. The first group, look at this first group. What can we factor out of this group? What can we factor out of this group? Well, both of these terms are divisible by x. Both these terms are divisible by x. So we can write this as x times x squared divided by x is x, and then 6x divided by x is 6. Now come to this second group. So what can we factor out from these two terms? Both these two terms are divisible by 2. We can divide this by 2 and this by 2. So let's factor out 2. So plus 2 times 2x divided by 2 is x, and then 12 divided by 2 is 6. Now we have two terms. Again, we have two terms, this term and this term. We have two terms. If we look at these two terms, we will see that x plus 6 is a common factor. X plus 6 is here, and x plus 6 is here. So we can factor out x, we can factor out x plus 6. So let's do that. X plus 6 times x plus 6 times x, this x plus this is plus, and this is plus 2. So we have factored our expression. So the factors of x squared plus 8x plus 12 are x plus 6 times x plus 2. Now let's see another example. This is a little bit uh, difficult. This is a little bit difficult. We are supposed to factor 35k squared plus 100k minus 15. This is a non-one coefficient expression, because instead of 1 we have 35 here. So it's a non-one coefficient quadratic expression. If we look at these three terms, this term, and this terms, we can see that all these terms are divisible by 5. We can divide all these terms by 5. So let's do that. 5 times 35k squared divided by 5 is 7k, and 100k divided by 5 is 20k, and minus 15 divided by 5 is minus 3. Now we are going to split this term in k into numbers. We will split this term in k in two numbers in such a way that the sum of those two numbers is plus 20, and the product of those two numbers must be 7 times multiply -3. So let's those two numbers be a plus b, then a plus b must be equal to plus 20, and the product of those two numbers, a multiply b, must be equal to 7 times negative 3, which is equal to minus 21. So we need two numbers whose sum is plus 20 and whose product is minus 21. So think about two numbers. Their sum must be equal to plus 20 and their product must be equal to minus 21. So what about plus 21 and 1? Plus 21 and minus 1. Plus 21 minus 1 is equal to plus 20. And plus 21 multiply minus 1 is equal to minus 21. So plus 21 and minus 1 will work. So let's break this 20k into plus 21k minus k. Now let's write the remaining terms. That is 7k squared and minus 3. And no doubt this 5. We should not forget this 5. Now we have 4 terms. 4 terms, 1, 2, 3, 4. So we can group. This is the first group. This is the second group. So what can we factor out of this first group? Very easy. We can factor out k, 7k from here. Both these terms are divisible by 7k. 7k, we can divide this by 7k. We can divide this one by 7k. So let's do that. 7k times 7k squared divided by 7k is k, and then this plus, and then 21 divided by 7 is 3. Now, what can we factor out from this group? We can factor out minus 1. Minus 1, we can divide this by minus 1. We can divide this by minus 1. So minus 1 times k and plus 6, because minus 3 divided by minus 1 is plus 3. And no doubt this whole into 5. So now we have one term and this another term. And if we see k plus 3 is common in both these terms, k plus 3 here, k plus 3 here. So let's factor out k plus 3. K plus 3 times 7k minus 1. And this whole into 5. So we have factored our quadratic expression. So the factors of 35k squared plus 100k minus 15 are 5 times k plus 3 times 7k minus 1. I hope you learned this